Hello, in this video we're going to take a look at another type of special sequence, the geometric sequence. So a geometric sequence is a pattern of numbers where to get from one number to the next, you multiply by a specific number. So in this case, maybe times 3, times 3, times 3 as you keep going. Or maybe you multiply by a fraction, that is, you divide by a specific number. So maybe you're at 50. 25, 25 over 2, 25 over 4. So in this case, I'm multiplying each number by 1/2. Or you could think of it as dividing by 2 each time. That's a geometric sequence. So different from arithmetic, because arithmetic is where you add or subtract to get to each number. But geometric is where you multiply or divide to get to the next number. And there is a specific rule that we can use to describe a geometric sequence. Again, we won't go into deriving it, but we'll just lay it out here. A sub n equals a sub 1 times r to the n minus 1. So understanding this notation, a sub 1 is the first term in the sequence. R is the common ratio, that number you'll multiply or divide by to get to the next number. And n is the term of the sequence you are on. And that allows us to find, maybe the 20th term in a sequence by finding a sub 20. And you can immediately and directly find the 20th term without finding the ones before it. So I have this sequence, 4, 8, 16, 32. Let's write a rule for it. Now, is it geometric? Well, I think we can see with our eyes that to get to the next one, you multiply by 2, multiply by 2, multiply by 2. So we can see it's geometric. But the surefire way to check that is by taking a term and dividing by the previous term. So that equals 2. Check it again. Take one term and divide by the previous one. It equals 2. Take another term, divide by its previous term. It equals 2. This number here, it should always be the same, and that's your common ratio. That's what you multiply or divide by to get to the next one. So we have a 2. So we have a sub 1 is equal to 4. That's our first term. Our common ratio is 2. So therefore the rule is a sub n equals first term times the common ratio to the n minus 1 power. And with that, we can find any term in the sequence. So why don't we quickly find the 10th term? So that would be 4 times 2 to the 10 minus 1. So I'm going 4 times 2 to the 9th power. And geometric sequences often get very big, very quick, okay, because we're dealing with exponentiation. So I have 4 times 512, which gives me a final answer of 2048 as the 10th term in the geometric sequence. Let's try another harder version. This problem asks us to write the rule for the geometric sequence where the 4th term is 24 and the ratio is 3, and then find the 12th term. Well, in order to write a geometric rule, you need to find both the first term and the common ratio. So right now, I do have the common ratio. It is 3. I need to find the first term though. So we use the information we're given. The fact that the 4th term is 24 means that a sub 4 equals the first term times the common ratio to the 4 minus 1 power. Okay, n is 4 in this case. And what does that equal? 24. So we know that a sub 1 is equal to 3 to the 3rd power, which equals 24. So a sub 1 times, let's see, what is 3 to the 3rd power? 3 times 3 is 9, times 3 is 27. So we have this. So it looks like a sub 1 is equal to 24 over 27, and I can divide that or reduce that by 3, so I get 8 over 9. So using that information, we can write the full geometric rule. First term times 3 to the n minus 1 power. And then we can find the 12th term like this, 8 over 9 times 3 to the 11th power. 3 to the 11th power, that's 177,147. And we just need to multiply that by 8/9 to see what we get. So when we do that calculation, we get that the 12th term is 157,464. Okay, so we use the information that the fourth term is 24 to help us find the first term in the sequence. Want to go up one more level? Let's try it. Okay, top level here. Find a sub 14 for the geometric sequence where a sub 4 is 125 and a sub 10 is 125 divided by 64. In this case, I do not know either the first term or the common ratio, so I need to figure out both. What we are told is that a sub 4 equals 125, which equals the first term times r to the third power, because that's n minus 1. We also know that a sub 10 equals 125 over 64, which is going to equal a sub 1 times r to the 9th power. Well, if we look at this, we notice we have two unknown variables and two equations. So we're going to use a system of equations to solve this. I'll write that over here. We have a sub 1 r3 equals 125, and we have a sub 1 r9 equals 125 over 64. I think that we can solve this one with substitution. So I'm going to solve for a sub 1 in the first problem. That gives me that a sub 1 equals 125 over r cubed. And I'm going to take that, plug that into the other equation. And we get 125 over r cubed times r to the 9th equals 125 over 64. Let's see if we can solve for r. Well, by laws of exponents, you subtract there, so I end up with 125 r to the 6th equals 125 over 64. I'll divide by 125, divide by 125, so those cancel, giving me r to the 6th equals 1 over 64. Opposite of r to the 6th power is taking the 6th root. The 6th root of 164, so that distributes to the top and the bottom. That is 1, and then there, if you think about it, 2 times 2 times 2 to the 6 times is 64. So I get 1/2. So 1/2 equals r. Plug that in up here, if we can follow all the arrows all around here. And I can figure out that a sub 1 equals 125 over 1/2 to the third power. So a sub 1 equals 125 over 1/8. Dividing by 1/8 is the same as multiplying by its reciprocal. So we end up with 125 times 8. 125 times 8 is 1,000. So we have that a sub 1 is equal to 1,000. Finally, let's put that all together in my rule. A sub n equals the first term times the common ratio to the n minus 1 power. And now we can figure out a sub 14 is equal to 1,000 times 1/2 to the 13th power. And this is going to give us a pretty small decimal, because 1/2 to the 13th power, it's a 0.0001207033125 if you want it all. But then when I multiply by 1,000, it gives me a little bit more manageable number, and I'm going to leave it in decimal form instead of finding the fraction. And there we go, that's the 14th term. So we had to use a system of equations and then substitution to be able to find a sub 1 and r. Just remember, whenever you want to write the rule for a geometric sequence, you need to find both the first term and the common ratio.